Jai Hind to all. My name is Babita. I am assistant professor in MCA department at Akgec Kumar Garg Engineering College, Ghaziabad. So today I am coming with a new lecture in the series of computer network. The code is BMC 303 and this course is derived from the MCA student and basically is more beneficial MCA third semester students, right? So today's topic is a leaky bucket and the mainly uses of the leaky bucket in a computer network. So let's start this lecture with the core concepts. So outcome of this lecture, the learner definitely learn about the basics of the leaky bucket. We are talking about the why we need of the leaky bucket, and next we will talk about the why leaky bucket is important for us. And next we will talk about the introduction, a basic scenario or basic core concept of the leaky bucket. And next we will talk about the working process, and last one we are talking about some pros and cons, right? So let's take brief description, or you can brief overview about the basic foundation, because leaky bucket is a subtopic of computer networking, and this topic is mainly covered the concept of a transport layer, right? If I'm talking about the congestion, right, because where is considered or where is implementing the situation when we have the congestion, in which we are talking about the some kind of mechanism, and in which in these mechanism leaky bucket is also an important concept. So first of all, we are talking about why we have the requirement of studying to this topic. So first of all, we have a situation, and this situation is nothing but it is a congestion. So basically, if you work with the leaky bucket process, or you understand the concept of a leaky bucket algorithm or concepts, you first need to understand the concept of congestion. So congestion occur when too much data is sent through the network at the same time, because it causes the delays, packet loss, and even network collapse. So basically, if I'm taking a real life example, what is the concept of a congestion? Congestion is a situation where some kind of problem is arise. The process is halt and process is stopped. The process is nothing but it is a transmission. So the process of transmission is stuck due to some collapse and due to some एक तरीके से strictness, right? So basically this is similar to a traffic jam on an highway, and when too many cars trying to move at once, and every slow down the process, right? How it will work, by taking an example, let's say ki here we are using some kind of situation, and this is a highway, and here we are only a single pathway, and let's say ki one car is moving through this direction and one car is moving through this direction, but the space is not enough ki both car can pass smoothly towards the each other, right? So here we have the situation, let's say ki this particular car is moving in this direction, and it will come at that situation, and this car is also moving in this direction, and this will come in at this situation. At this situation both car are stuck and both car are एक तरीके से क्या हो जाएंगे, यहाँ पे जाम हो जाएगा. अब now the new incoming cars from the both directions stuck in this area. So this is the congestion, because this process, this situation is stop the process of the moving car, right? So in the same scenario is implementing on a network, because network is a single line or single path between the sender and receiver. If some situation is arise कि यहाँ पे क्या हो गया, एक तरीके से एक स्ट्राइक हो गया है किसका, एक इनकमिंग पैकेट्स का. लेट से यहाँ से भी कुछ पैकेट्स ट्रेवल कर रहे थे, यहाँ से भी कुछ पैकेट्स ट्रेवल कर रहे हैं, और बोथ पैकेट्स आपस में क्या हो गए हैं, स्ट्राइक कर गए हैं. दिस सिचुएशन इज congestion. So congestion control technique is used to overcome the to come out from this situation. So basically the main concept of the congestion control techniques or mechanism is to prevent, detect and manage congestion, and it is a main goal of this of these techniques to maintain the smooth data transmission or smooth data flow and fair bandwidth allocation and efficient utilization of network resources. So basically, for which we are doing that type of a scenario to ensure the stable and reliable network performance. So this is the main reason कि we have the requirements to control the congestion. And how can we control these congestion? By using some techniques. So basically, in the next terms, we are talking about the flow control, because this situation is arise during the congestion because the flow is stopped, and this technique ensure the proper management of the data flow between the sender and receiver, and especially when the both operate at a different speed or processing, because the communication always done with between the sender and receiver. Here we have the sender and here we have the receiver. Let's say the sender sends 1000 packets per minute, but receiver receive only 100 packets per minute. So what happened here, there is a situation ki some particular packets may loss because receiver speed not matching with the sender speed, right? So here we have the approach that we will work on it, that is a flow control. Flow control that tells about कि सेंडर को रिसीवर के अकॉर्डिंग अपने डेटा फ्लो को मैनेज करना है, और यू कैन से द पैकेट्स उसको उसी के सिंक्रोनाइजेशन में सेंड करना है, राइट? इट हेल्प मेंटेनिंग द बैलेंस बिटवीन द डेटा ट्रांसमिशन एंड द receiver by the receivers and the memory capacity, right? So this is the main situation. That's why we are a requirement of a traffic shaping, or you can say the congestion control mechanism. So in which we are talking a traffic shaping. Traffic shaping, that means we have to shape the traffic in a smooth or seamless process, because the communication is done smoothly by using this particular approach. So traffic shaping tells about the process by regulating of network traffic to achieve the desired quality of service. Because if data transmission is going smoothly without any congestion, without any means एक तरीके से flow control, या you can say the by mismatching of flow, that means the network may achieve the quality of service, because the performance is high, because there is no congestion and no requirement of flow control and no delay and no traffic shaping, the traffic is not occur at that situation. The primary purpose of the traffic shaping is to prevent a network congestion by limiting the amount of bandwidths used by the non-critical applications, right? And it also tells about the bandwidth management techniques, because flow control, that tells about the flow of data through the network to optimize the performance and ensure the quality of service of and higher priority applications. Next, traffic shaping techniques also determine the essential of managing network traffic and ensuring optimal performance of the network. So here we are the concept that is a leaky bucket. Leaky bucket, here we have some incoming packets that is sent by the senders, right? And these packets sent by the sender in a busty form, right? So when data is flow on the network, it may be a in the form of a static, or you can say in a fixed nature format, or you can say in a busty format, right? So busty, that means you have a lots of packet and you sends at the simultaneously, right? So when the data is incoming in a busty form, but the leaky bucket concept provide a mechanism to make the this particular data at a constant rate, because when it transferred, yeah, at a constant rate. So how can it will work? Let's take an example, or let's take the working process of the leaky bucket. Let's say here we have a tap, and this tap flow the water at the varying rate, right? Let's say kabhi zyada kabhi kam. So here we have a varying rate of transferring, yeah, of delivering the packets of the data, right? So this particular scenario is considered as this particular flow of data is considered as a busty flow, because in this have no particular arrangement of the data. It may be a high or it may be a low. So this situation is considered as a busty flow. But here we have a particular bucket, and in this bucket at the bottom we have a hole. Let's take an example कि हमारे घर पे एक डब्बा है और उस डब्बे में हमने क्या किया हुआ है, बहुत सारा पानी फिल कर दिया है, बट एट द बॉटम हमने एक उसमें होल किया है, एंड विद थ्रू दिस होल द रेट ऑफ द डेटा या रेट ऑफ द वाटर इज कंसिस्टेंट या इज कांस्टेंट, बिकॉज द फ्लो इज मैनेज्ड बाय दिस ओनली होल. देर इज नो पॉसिबिलिटी कि कभी ज्यादा कभी कम नहीं. द फ्लो ऑफ वाटर इज implementing, yeah, is flowing at the constant rate. So basically what it happened here, the concept is followed a particular managing situation in which we are flow the data at the fixed rate. Fixed rate, that means let's say at a one time only 5 Mbps packet is travel, yeah, is flow in this whole, right? So this is a fixed nature, or you can say the constant rate. So let's take, this is the scenario of a busty data flow, and this is the scenario of a fixed data flow. Yeah, you can say the constant data flow, in which we have the varying flow of the data. Let's say at a one time 12 Mbps, and at the next moment it will be a 2 Mbps. There is no proper arrangement, but here we have a constant at the all time, yani ki all time of the data is travel at the constant rate. It, let's suppose ki it will be a 3 Mbps. The all time of the data will 3 Mbps, not the sometime is 4 and sometime is 5. Not, this is not the case in the fixed data flow rate, or you can say the constant flow data rate. So in this previous slide we are talking about this type of scenario. So basically leaky bucket algorithm controls the flow of the packets that is sending by the sender, and it out at a station out at a constant time. Yani ki sender is sends at any rate of the sends the data, but it always out at a constant rate. This is the main point of view of this topic. So fixed rate and regardless of incoming burst traffic. So traffic is considered as a burst in nature, but the flow of data through the leaky bucket algorithm is always as a fixed rate, right? Packet are placed into a bucket, or you can say into a queue, and if the bucket overflow, then means that means the some packets may discarded, because you also considered as your real situation. Let's say ki this is the bucket and it has a specific size, and this bucket is implementing in a technical terms considered as a queue. Let's say this queue have a specific size, and this size already fixed by the programmer, or you can say the system, right? Let's say ki this particular queue is filled, right? Now some packets is incoming from the sender sides. So what happened here, these particular situation discard the all incoming packets because queue is already full. So जब मतलब बकेट के अंदर हमारा पानी फिल होता है और पानी हमारा पूरा भर जाता है, तो क्या होता है, क्या जो भी हमारा एक्स्ट्रा वाटर होता है वो पानी बकेट से बाहर गिरना शुरू कर देता है. तो सेम सिनेरियो इज इम्प्लीमेंटेड इन द leaky bucket concept, right? Because here we have a queue and this queue have a some kind of fixed size, and whenever this fixed size is filled by the packets or incoming packets, or let's say some other packets is incoming from the sender side, so it will be discarded because there is no enough size to, there is no enough space to store that packets. So this ensure the smooth traffic but waste bandwidths during the idle time. This technique is more beneficial because it provides the smooth traffic controlling, you can say the data flow, control the data flow, but it always, it also wastes some kind of bandwidths if this particular become ideal during the execution, during the implementation. So next we will talk about the advantage. It provides the smooth bursty traffic transmitting at a fixed rate, or you can say the constant rate, right? Excess packet, excess, that means extra packets. Extra packet are discarded if the buffer, or you can say if the queue is a overflow, right? And how can we understand? Example, ensure host sending burst only transmit at a fixed, or transmit only at its committed 3 Mbps, because here as you seen here ki we in advance already fixed ki transfer always implementing at a 3 Mbps. That means all time you are sending only 3 Mbps data at a time, right? So this will provide a constant rate because you are fixed the size of the data during the flow out from the queue, right? So whatever the speed of the sender, whatever the speed of the receiver, no matter, because you are fixing a scenario of transferring, or you are fixed the rate of outing the packets from the queue, from the buffer. So what happened here, let's say if I am taking an example, let's say this is a sender and this is a receiver, and here sender is sending 1000 packets per second, right? But its speeds is 100. So in between we are fixing a particular approach in which we are incoming data is stored in this buffer. This memory buffer is provided by the network administrators, right? And this particular data is stored here, and from here a particular data rate is fixed by this algorithm. Whatever algorithm is working, and we are talking about the mainly leaky bucket algorithm. Just suppose here working is a leaky bucket. So leaky bucket provide the approach ki in a what data rate sender sends the data, no matter, but a receiver receive a particular constant rate. Let's say ki it will receive 100 Mbps data at a one time, or you can say per second. So basically what happened here, a smooth transmission or a smooth flow of data is covered by the receiver, right? So this is the main approach. Next we will talk about the advantage of the leaky bucket. So basically leaky bucket is a very important algorithm, and another we have a algorithm just similar is a token bucket. So token bucket we will talk about in a next lecture, because these two main algorithms that will control the flow of the data. So leaky bucket is mainly important in a traffic shaping scenarios where we have to shape the traffic, because the traffic on the network एक तरीके से ड्राइव या it will cause the congestion, because if your path have the lots of traffic on the network, so basically there is the problem of congestion, and congestion is a cause the problem of loss of packets and delay in the transmission. So basically this is very important in a traffic shaping, right? And the next, leaky bucket is a important mechanism of congestion control. If I am talking about the some kind of primarily techniques used to control the congestion, so the first we will talk about the leaky bucket approach, and also work importantly work for a quality of service enforcement. If I am talking about the quality of service, so in the quality of service of a network, we will consider as a performance, bandwidths, delays, latency, throughput. So basically this all achieved by using a leaky bucket approach, and it provides the smooth transmission in the case of a bursty traffic into by converting into a constant flow of the data, right? And next, it will provide the prevention from the network congestion, and it ensure the fair bandwidth allocation, or you can say the fair bandwidth uses by the participants in the wired or wireless, or you can say in a IoT. That means in IoT we have a lots of devices that will work Internet of Things and real-time communication system. So basically it most widely used in a very various application areas. It may be considered as a wired network areas, yeah, you can say IoT, Internet of Things and real-time communication system. So basically this is the topic of leaky bucket, and I hope you will understand betterly, and thank you so much.